S. Chand presents educational video lectures as per the AICTE curriculum. Difficult concepts made easy. Study anywhere, anytime.
Fourier series, a special series given by Fourier. And if you have studied series concept, in series concept we learn convergence and divergence. If a series is convergent, we say that it has sum, but we in that concept we never define a sum, but Fourier has given sum of some special series, and we'll learn in this topic that how come a series has a series sum is defined. Hello everyone, I am Dr. Seema Thakran. Welcome to S. Chand Academy. If you want to learn engineering mathematics, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. In this lecture, we'll be learning Fourier series, what exactly Fourier series, and in a Fourier series of a function, what conditions a function should satisfy so that we can write a function Fourier series. And then we'll come to the concept of if a function is defined in terms of Fourier series, how we define and how we check convergence, and then how we define the sum at some particular points. So let's start with the lecture, Fourier series. So first I'll define what exactly Fourier series is. Normally we know what if there is a sequence, we add the terms of the sequence and we say that this is Fourier series, this is series, but this is special series because it's not kind of normal series. So let fx be a function in the interval, and it is closed interval. So this is one thing you notice. It is minus pi to pi or 0 to 2 pi. So if you have a function in the interval minus pi to pi, then if fx is periodic, it means the function you are taking or considering to write the Fourier series, it should be periodic. Number 2, it should be bounded. F be bounded. This is bounded. And if I'm saying it is periodic, it is bounded, obviously I am considering the domain as minus pi to pi. It is understood. Then fx is finite. A function is fx, this is the interval, periodic, bounded, finite, then the Fourier series of f in the interval minus pi to pi, this is closed interval, not open interval, is defined as, now I am finally writing the Fourier series, and the Fourier series is a naught by 2 summation an cos nx dn sin nx. Here n is natural number, n from 1 to infinity, and natural number starts from 1. A naught by 2 is separate. So this is the Fourier series. Now a naught, what are these constants? So these constants are defined by Euler formulae. I am writing the Euler formulae. So my a naught will be calculated by this formula, because the series I have written, but what is missing? A naught, an, bn. It means you need to have the formula for a naught, an, bn, and this will depend on fx. It means through the function fx you will calculate a naught, and this is 1 by pi limits from minus pi to pi fx dx. An is 1 by pi minus pi to pi fx cos nx dx. So these integrals you will calculate and you will write the values. You will get the complete series, that is Fourier series. fx sin nx dx. These are called Euler's formulae, A naught, An, Bn. If you substitute these values in the series, you will get the, in general, the series you will get it. Now, next is your function f is any function. Whenever you do any question of Fourier series or you are doing the concept of Fourier series, if you have any question, what you do first thing what you have to do, just check whether your function f is even or odd. Why it is useful or why it is important, I'll let you know. Suppose f is even. Suppose your given function is even. It might be that there are cases that a function is neither even or nor odd, but if the function is even or odd, it will become very it is very helpful. And how come? That I am explaining you. So suppose your function is even. Even means your fx and f of minus x. It means if you are changing x to minus x, you are getting the same function. And on the basis of this property, you are saying your function is even. If your function is even, it means a naught, that is minus pi to pi fx dx. What change will be in a naught? I am writing that change. This function is even, and you know the property. In your 12th class, you have done the property that minus a to a fx dx is basically twice 0 to a f dx, fx dx. It means you just do the twice and limits will go from 0 to a. The same thing we can do because the function is even. It means this will be, the formula will become 2 by pi and the integration part anyhow gets easy. That is why you should check if the function is even or odd. If it is not, then you have to calculate it as per the formula. Then the same thing, an. What will be an and bn if in case it is even? So minus pi to pi fx cos nx dx. In this case, see carefully. This function is even and this is also given even because we have assumed it. Even means it will be even finally. So it means you will make it twice and 0 to pi when the function is even. Now come to bn. So bn is minus pi to pi fx sin nx dx. We have another property also. If your function is odd, if even, it will be twice. If odd, it will be 0. This value will be 0. It means now in this case, see, this is even and this is odd. Even odd combination is odd. It means this value will be 0. The thing is that if your function in starting you are checking and it is even, only you have to calculate a naught an, no need to calculate bn. Now come to odd property. If your given function is odd, what does it mean? Fx is minus f of minus x. It means this property it is holding. That is why on the basis of that we are saying it is odd. Now, if it is odd, a naught, that is 1 by pi minus pi to pi fx dx, it will be 0 now as per the formula. Then an fx cos nx dx, what it will be? This is odd and this is even. Even odd combination is finally odd, so it will again be 0. So it means if your function is odd, only bn you are supposed to calculate. Why? That you can see now easily. This is odd function. Sine function is also odd. Cos function is even, sine function is odd. So odd combination becomes even. It means this time this formula will get twice and limits will be from 0 to pi sin nx dx. So your Euler formula is converted to if, I just summed it up. In brief, I write if f is even, you have to just calculate A naught an with the twice formula, and if f is odd, you have to calculate only Bn. It means in this case your series will look like an cos nx, this much only, and in this case the series will be this Bn sin nx. And you focus on the angle also, cos and sin both have nx in the angle, and n is a natural number, n from 1 to infinity. So this is your Fourier series. In different situations we have discussed that if function has is even odd, how we write the series. Now coming to the point, the sum of the series, Fourier series. And one more important thing, if you are noticing, you are connecting one function to a series. It means you are expressing a special function which is periodic, which is bounded, which is finite, a special function to a series which is Fourier series, and then on the basis of that you are now you will be calculating sum. So sum of this Fourier series at points. Now it will matter what type of point it is. What type of point it is? It will be if x is suppose a and at this point function is discontinuous. Function is, it means it will matter like what type of point you are calculating this sum. If this is the point and you are asked that at this point check the Fourier series sum, then because this is discontinuous point, and you know that for discontinuous point what you will do, you will take the left limit, you will take the right limit, and this we do in continuity. When we check the continuity, discontinuity, what we do, we find the left limit, we find the right limit, and then we check whether it is same or not. If it is same, then we say it is continuous, otherwise we say it is discontinuous. Now this will be the sum then. If for a point which is discontinuous, this will be the sum. If the point, and the point is this, at this point, suppose I am taking this time B, if this is the point and at this point function is continuous, then simply we say the sum will be Fa. The sum will be, Fb, because B is the point. Now, in the second part of this lecture, we will be discussing what will be the sum at the corner points, that is plus minus pi, and with the help of the example we will be understanding. So, in the next part, we will be taking that example. If you want to learn engineering mathematics, please refer to the book by S. Chand Publishing. The e-book link is given in the description box below. If you like the video, please do like, share and subscribe S. Chand Academy. Don't forget to press the bell icon for the future updates. Stay connected, stay tuned, keep watching upcoming videos. Thank you.
All rights reserved. This video has been prepared for educational purposes only. No part of it may be reproduced or copied without the permission of the copyright holder.